Hello learners, welcome to my YouTube channel. Previously, we were on the structure of the atom and the periodic table for lesson 2, where we were defining and dealing with the isotopes, energy level, and electron configuration, or what we have said, electron arrangement. So in this lesson 3, we are going to be dealing with the periodic table. Okay, what is the periodic table? So periodic table is the representation of elements using columns and also rows, and they are representing these elements based on their atomic number or according to their atomic number. So elements with the same number of electrons in their outermost energy level form a group. For example, hydrogen, lithium, sodium, potassium have one electron in their outermost energy level. Hence, they belong to the same group, which is group 1. Here, you are supposed to know, first of all, how to write the electronic configuration of an element. For example, the electronic configuration of element of hydrogen is 1 because the atomic number of hydrogen is 1. And we said the first energy level occupies a maximum of 2 electrons. So if it is 1, that means the last energy level of hydrogen has 1 electron, and that one is the one that makes hydrogen to be belonging into group 1. So go to lithium. Lithium is number 3. So for lithium, if it's number 3, to write its atomic number, it's 3. To write the electronic configuration, it will be 2 for the first energy level, and also the other one will go to the second energy level. So check the last energy level, it's having 1 electron. So it is group 1. If you want to know whether an atom or an element belongs to a certain group, you are expected to write the electronic configuration of that atom or element, then you check the number of electrons that it has in the last energy level. That number will be the group to which that element belongs in the periodic table. So next, we are told there are 8 groups in the periodic table, and these groups are written in Roman numerals or Roman numbers. Like if you are dealing with group 1, you are supposed to write Romeo 1. If you are dealing with group 2, you write Romeo 2. If you are dealing with group 3, Romeo 3, like that, up to group 8. And we said group 8, they are also referred as group 0. We are going to come to it. So next, elements with the same number of occupied energy levels level form a period. Like for example, if you want to know whether a certain atom or elements belong to a period, you are supposed to write the electronic configuration of that element, then you count the number of occupied energy level to which that atom has. So for example, if you are dealing with the lithium, the atomic number of lithium is 3. Writing the electronic configuration will be 2 to 1. So to check the number of occupied energy levels, we have 2 occupied energy levels. So lithium will be in period 2. So writing the period, you can write in numbers form. So let's start. For example, hydrogen and helium have 1 occupied energy levels. Hence, they belong to the same period, and that's period 1 in the periodic table. So in the periodic table, there are 7 periods. You have to know. Previously, we have said the periodic table has got 8 groups. We have written here, the periodic table has got 8 groups, but the number of periods that the periodic table has, they are 7 in numbers. So let's just try to check. Next, we are told between group 2 and group 3 lies a group of elements referred to as the transition element, or you can say transition metals. Examples of those metals or elements, they include iron, and also we're having copper. But apart from this, we're also having something called gold there, we're having silver there, and many others. So these elements have some unique characteristics that make them not to fit in the 8 groups of the periodic table. Some of these characteristics were, these transition metals were having colored ions. They were having colored ions. Then the next one, these transition metals were having variable valences. Variable valences. So these are the 2 characteristics, unique characteristics that make them not to fit in the first 8 groups of the periodic table. So let's just try to have a look on the periodic table. So the periodic table look like this. The periodic table look like this. So here we're having group 1. So here we are having group 1, we're having group 2. So we are having group 3 here. So in between group 2 and group 3 lies a group of elements which are in block D, These ones are the ones that we have said they are known as transition metals or transition elements. So these ones, they have some unique characteristics that make them not to fit in the first 8 groups of the periodic table. So group 3, group 4, group 5, group 6, group 7, and group 8, which we said you can also say they are group 0. So have a look on the groups. They are written in Roman numerals or Roman numbers. If we check on this other side of periods, we are having 7 periods. So this is the first, second, third, fourth, sixth, fifth, sixth, and seventh. But in the first 20 elements, we are going to have up to period 4. But in the periodic table, complete periodic table, we are having 7 periods and also 8 groups. So during the exam, they may give you a grid which has 3 or 4 rows. And during the exam, they can tell you how many more rows required to be completed the periodic table. So you are supposed to say 7 minus the number of rows that were given in that grid. Okay. Thereafter, let's go to the extended question. Attempt the following question. So I want to do for you the first question, and you are going to do the second and the third question. So example 1, number 1, you are told an element Q has an atomic number of 13. So write the electronic arrangement of Q. So if we are having atomic number of 13, we said atomic number and number of electrons are the same. So this element has 13 electrons. So to take 13 and distribute into the energy level, the first energy level takes carries a maximum of 2. So 13 minus 2, I'm going to get 9. So I'm going to get 11, sorry. So this 11, all of them, they go to the second energy level, but we say second energy level carries a maximum of 8. So it cannot carry more than 8. So 11 minus 8, I'm going to remain with 3. So this 3, they go to the third energy level. So the third energy level, we said carries a maximum of 8 if that element is in the first 20 elements, and 18 if it's not the first 20 elements. So that means I'm going to have 2A3 as the electronic arrangement or electronic configuration of that element Q. So next, let's go to part B. We are told to which group and period does that element Q belongs while giving reason, or you have to give a reason. So I said, if you want to know the group to which an element belongs, you are supposed to check the outermost energy level. How many electrons does it have? Here it's having 3, so that means element Q belongs in group 3 in the periodic table. 3, you are going to write in Roman numbers. Reason, this is because it has 3 electrons. This is because it has 3 electrons in its outermost energy level. It is outermost energy level. So you are done the reason like that. So next, you are told, what about period? Which period does it belong? So we said period. If you want to know the element to which period belong, you are going to check the number of occupied energy levels. These are occupied energy levels. So here we are having 1, 2, 3. So that means it's in period 3. Remember, we are told you can write period in number form, numerals. So reason, because it has, this is because it has 3 occupied energy levels. 3 occupied energy levels. Full stop. So students, try to attempt 2 and also 3, question 2 and question 3, and try to submit or write your inferences, I mean your answers and comments on the comment section. Inshallah, goodbye. So let's meet on the next class as we look on isotopes and relative atomic mass. Thank you.